Okay, so yesterday I recorded a video showing how you can do image manipulation Houdini using shaders. And I'm going to show something similar today using COPS, which is the compositing network. Now, obviously, compositing is image manipulation, but specifically, I'm showing how to do it using geometry and using a new node called Labs Attribute Import. Um, so, traditionally in compositing, you export different masks and then you combine those in the compositing step. But we can skip that and just use our original image and use geometry attributes like primitive attributes to change it inside of COPS. So for starters, I'm going to create well, first of all, I'm going to save this project here. Let's call this Toot 3. So let me just check my recording. Okay, so for starters, we're going to create a cop2 net here. Not in the object level, sorry. We're going to create a geo level. Go in here, create a cop2 network. Go inside of it, create a file. Import our image. So yeah, I already had this image loaded. So here we can see it in our scene. So we're going to go back to the geo level here. And we're going to create a grid. So basically, we're creating a grid which has the same size as it. Now, if you go into this COP2 network, you can see there's this size thing right here, right? That is not the like size in Houdini units of the picture, right? That like this isn't like I don't know. I forget what I think Houdini units are in meters. So if I used 2048, that'd be a massive grid, right? And you can see right here that this is within the -1 to 1 space. So I'm not using this size here. Instead, what I'm doing is I'm going to use the bounding box of this cop2net output. And if you middle click on the cop2net, you can see we're getting 3 million primitives, one primitive for every pixel. But it's all has a physical size. The physical size is important here. So that's what we're going to use using bounding box. So we're going to say we're going to do bounding box expression based on the cop2net. We're going to get the dx size. Then we're gonna do the same thing. Ooh, what did I do? Oopsies. Okay, and we're gonna get the Y size here as well for our grid. And now if we look at our grid, we can't see it because it has the wrong orientation, but now you can see that they have the same size. Okay, and we can make our grid have 2 rows and 2 columns. So now I'm just going to split this up and make like some different primitive regions. So I'm going to display my original image and I'm going to do a curve polygon. This is just quick and dirty. I'm not like showing anything like real world here. I'm just doing a demonstration. Okay. So now I'm going to do a Boolean between our grid and the curve. And this is going to give me something with two prims in it. Okay. So now I'm going to just do some attribute create stuff. So I'm going to first create an attribute called region that lives on the primitive that has a value of 0. And I'm going to do this one more time. And this time I'm going to also say region on primitive, and it's going to have a value of 1. I'm going to apply this only to the center primitive here. So now we can use a visualize attribute here to see it. Let's see. So we're going to see attribute region. Let's see if this works. Give me 1 second here. Sorry, I'm not that well practiced with using the visualize node, so I'm just going to do that again. I'm trying to get better at that. So visualizers, we're going to call this region class primitive. There we go. So now we can see actually if we do attribute as is, right? So you can see our middle thing has a value of 1 and our outer has a value of 0, also in geometry spreadsheet. So now we're just going to do a UV project to get some UVs, which is required to bring it into COPS. And we can turn off our visualizer. Yeah, you can see our UVs there. We're going to make a null here, which is going to be our, we'll just say like masked Gia. Now I think traditionally what you'd do is you'd render this as a separate pass, right? So you'd get this sort of mask image, but we can skip that and just bring it into cops. So we're going to make another cop2 net right here. And inside here, we're going to bring in our original image again. And now we can actually go to the composite view. We can see our image here. This is already loaded up here. And then, so what we're going to do is we're going to be manipulating our image using a VOP Cop2 filter, which is a scary name, but it's just a kind of a free-form place to manipulate the image using Vex code. So we can plug in our first input here, put our visualizers in here. And all these global variables are kind of esoteric, but there's R, G, and B for the color. There's X and the Y for the UV position, because this is being run at every pixel. Basically, it's kind of like a shader. And then there's all these outputs. And then we can also do this thing called, so you can use all these VOP nodes, obviously. There's a bunch of VOP nodes, but you can also do something called a snippet, which is a Vex context. And you can pass things into here. You can output things, but they're also um, all these globals are automatically available in the snippet context. You can read and write them, so you don't actually need this global and this output. So if you ever need them back, you think you can just do global variables and output. Yeah. So, but I don't need those. So we can just say right here. Let's just give an example. We'll just say vector ridge color is set RGB, okay? And now we're going to say vector new color is a ridge color times green. So we're going to make it kind of green tinted, and then to output color, we do the assign function, RGB new color. And now you can see it's green tinted. So that's all you have to do to change an image. And now, so cool. So now how do we get our geometry kind of masked attributes in here? So we go back to our cop level. And there's this node called labs attribute import. Now this hung me up for a while because I was thinking like, well, where is this node? Because I was inside the VOP context and I was like, labs, and there's nothing here. So you have to do it only at the top level cop network, okay? Cop context. So anyway, this attribute import here. So we're going to pick our geometry here in mask geo. So this is really important. Well, before that, so let's see the RGB. We're going to turn this into region. We're going to import our region attribute, okay? And now you can see it right here, right? So that's our region. And you might think, well, since we're just having a float attribute, why don't you just import that in alpha? It just doesn't work in my experience. So I'm just using it in RGB. This is just what worked. I'm not sure why, but basically it's taking this float and it's assigning it to the red channel. It's like the first available channel gets it. And this is really important here. If you see, this image has one size and this is a smaller size. So this is going to mess us up because the sizes need to be the same. So what we can do is go to our file node, copy this size parameter, paste it as a relative reference in the region of the, in the resolution of the labs attribute import. So now we have these images that are the same size. And yeah, and so now to get this into our VOP, I'm going to pass it as the second input here. So I'm going to dive into our VOP filter. And to get in here, I'm going to use something called cop input. So so I'm going to say so we're reading a 3D vector from pixel. And you might think, why don't we read a float? I just couldn't get it working. So I'm just using 3D vector for everything, even though it is a float attribute. I don't know why, again. And it's just what works. So the input index is going to be 1 because it's the second one, but we're using 0 indexing. Now we can't see anything because we're not like outputting anything. So we're going to do our val into our snippet, the output here. And in the snippet, let's kind of use our, we can just multiply it, right? So we can just say our new color is our original color times, let's say, val. Okay? And so now you can see that's kind of what we expected. Everything else is blacked in. The middle part's multiplied by red because we have 1 in the red channel, right? So just some kind of side comments here. So the comp input, there's all these input parameters. If you go to the help page for this, you can see that these arguments all default to the value of global variables if they're not connected. So you don't actually need to pass any of these inputs unless you're doing a query on a different UV position, which I will talk about in a second. But the other point is that this is called val in here. You can also go into the snippet and rename the variable to region or to anything you want. And now the region variable is available in your vex. Okay. So now what actually happened? Why is this not? It's okay. Yeah. So there's some bugginess sometimes. You can have to change stuff around. Okay. So that's cool. I'm gonna get back to talking about this UV querying thing in a second. Like if you want to query nearby values, I'm gonna get back to that. Okay. But first of all, let's just do something more interesting in this snippet. So let's say instead of multiplying directly by region, we'll just say multiply by new, we'll multiply by something called mult. What is mult? Let's say it's a vector and it equals, we're going to use interpolation between, let's say, red and green. And we're going to interpolate by an amount. Now, what is the amount? It's going to, let's just say our float amount is going to be our x component of region. Okay? So now we can see that we're multiplying by green and the, you know, on the middle part and red in the outer part. Okay, so that's a bunch of magic right there. And if we want to soften this transition, we can just add a blur here because this is an image, remember? So we can actually just do a blur right here, blur that out, and now our, now we're gonna have a softer transition, right? So the other thing I was going to talk about was doing different values for U and V, right? Because so there is like, let's say a use case would be like doing a sampling nearby pixels, so something like a convolution filter. So there's a convolute node here, a convolve node. I don't know how to use this yet. I want to learn. I'm not very good at cops so far. But let's just say you kind of wanted to do this with Vex, right? How would you do it? Okay, so yeah, you could copy paste a bunch of these cop inputs here and just plug in like different values for U and V. That would work to sample nearby values. But that's a little ugly. I don't really like doing like VOPs type stuff like this, and especially, it hurts my programmer brain to copy paste like that. I would rather, and there is a for loop as well. But again, it's very, it's sort of, I would prefer to do it just with Vex code. So in Vex, there is something called C input. Okay, it's a function. And there's also B input, F input. So you can look at the docs for these. I think they're all the same, but they use like they're like different quality. I think C input is the lower quality one. And what you see is it samples the exact unfiltered pixel color at the given coordinates. So I can pass a custom U and V in here and get the color value, but what color value am I filtering? Because I can't say what, it doesn't have an argument for like, well, because I have multiple inputs here, right? So it's actually just going to be sampling the color from my primary input here. So in reality, I'm trying to sample the color of my secondary input. Now this is something common in Vex, right? Because in all the wrangles, you can only manipulate the first input geometry. Actually, no. Let me just forget that point. Yeah. So anyway, what I think the workaround here is basically you take your kind of mask image and then you put another VOP cop here. And then in here, you can just do a snippet. You can write your kind of convolution or whatever you're sampling using C input. Okay, you can do this in a loop in Vex, right? And you do your C input and then you output kind of a new image. I'm not showing this, but you can understand the concept if you wanted to do this. And so you're going to get a new image here, which is, using the sampling nearby points. And then you plug that in to the next bob. Okay, so that was a little abstract. Maybe I should show an example of it, but I don't have one prepared. So I'm just going to leave you with this for now. I don't know if this is really useful. I hope it was interesting. I'm finding it interesting to dive into cops. So yeah, take it easy. Bye.